This is Geometry, Lesson 1-5. Our topic is special angle relationships, and our objective for today is that you will be able to identify special angle pairs and use their relationships to find angle measures. So let's dive in today. Here we go. Okay, the first word is adjacent angles. Adjacent angles are two angles that share a common side, a common vertex, and no common interior points. So basically, if you're looking over at this picture, 1 and 2 are adjacent angles. They share this ray and they share that vertex, but nothing else. Same thing with 3 and 4. They share a ray and a vertex and nothing else. Your next one is Sorry about that. Our next one are vertical angles. Vertical angles are two angles whose sides are opposite rays. So if we're looking at the drawing, 1 and 2 and 3 and 4, those are vertical angles. They're opposite one another, they're opposing one another. Those are different ways that I think about those. The next are complementary angles. Complementary angles are two angles whose measures have a sum of 90 degrees. Each angle is called the complement of the other. So when you add up the two angles, they add up to 90 degrees. You can see that in angles A and B, 47 plus 43 is 90. And angle 1 and 2, notice they have that little red box that goes through both of them. That is the right angle marker. Our next one is supplementary angles. Supplementary angles are two angles whose measures have a sum of 180 degrees. Each angle is called the supplement of the other. So together, these two angles would make a straight line. You can see that angles 3 and 4, they together they go all the way through a straight line. They're 180 degrees. And the measure of angle C and the measure of angle B, 137 plus 43 gives you 180 degrees. All right, so we need to be able to identify angle pairs. Using the diagram to the right is the statement true explain. It says angle BFD and angle CFD are adjacent angles. So you want to start by finding those in our drawing, BFD and CFD. Now if you look back up at the definition of adjacent angles, they share a common side, a common vertex, but no common interior points. These two angles overlap on more than just a ray, which means that they actually cannot be adjacent. They overlap in all of this space. They are not adjacent. So you'd say false. The reason is they have common interior points. You do want to get used to writing reasoning. It'll help you once we get into the next chapter. The next one says AFB and angle EFD are vertical angles. Let's go find those. AFB and EFD. What you want to be able to do in order to have two angles be vertical angles is their sides need to be opposite rays. So you can say that AF and FD, those are FA and FD are opposite rays. But when you go from B to F to E, you're not drawing in a straight line. And that means that if you can't just trace those in a straight line, then they are not actually vertical angles. So you would say false, and the reasoning being that if you can't draw a straight line between those sides, it means that you don't have opposite rays. So FB and FE are not opposite rays. Ray FB and ray FE are not opposite rays. C says angle AFE and angle BFC are complementary. Complementary means that they add up to 90 degrees. So let's find them. AFE is 62 degrees and BFC is 28 degrees. So we just want to take 62 plus 28. 62 plus 28 is 90. So in fact, yes, this is true. Why don't you pause the video and try the rest of these on your own. You can now check your answers with mine. You should have gotten true for D, false for E, and true for F. All right. So one thing you need to be able to know is what type of information you can find from a diagram. So we're going to talk about that. There are some relationships we can assume to be true and there's some that we can't. So things that we can assume is that angles are adjacent. We can assume that angles are adjacent and supplementary, and we can assume that angles are vertical angles. So all those three things you can assume to be true from an unmarked diagram. Now the next three are things you cannot assume to be true. There has to be evidence to back this up. So you can't assume that things are congruent. You can't assume that something is a right angle or that angles are complementary. And so these are very important things to know. You need evidence for these last three to back them up, whereas the first three you can just look at a diagram and say, oh, that's true. So here, let's take a diagram and let's see what we can figure out from this. It says, what can you conclude from the information in the diagram? Well, if I'm looking at the diagram right now, the first thing that I notice is these little congruent markers on angle 1 and 2. So I can say that angle 1 is congruent to angle 2. That's one piece of information I could say. Now, I had evidence to back that up. That's why I can say it. The things that we don't need evidence to back them up are whether angles are adjacent. So if I'm looking at the drawing right now, I could say angle 3 and angle 4 are adjacent. I could say angle 4 and 5, angle 5 and angle 1, angle 1 and angle 2, or angle 2 and angle 3. All of those are adjacent angles. I can assume that to be true. The next thing is that you can assume that angles are adjacent and supplementary. So if I'm looking up there, I might notice that, oh, angle 5 and angle 4, those are adjacent and supplementary. Oops. Trying to erase, sorry. I abbreviated supplementary as sup. I might also notice that angle 3 and angle 4 are adjacent and supplementary. You can also assume that angles are vertical angles. So if I'm looking, it looks to me like angle 3 and angle 5, I can trace those rays, make a pair of opposite rays, and say that those are vertical angles. I can say angle 3 and angle 5 are vertical angles. So those are all true statements I can make from this diagram. I want you guys to take a look at this next diagram, pause the video, and see if you can say that these statements are true or not. Let's check our answers. The first one, segment TW is congruent to segment WV. I can say that is true because they are marked congruent. The next one, that segment PW and segment WQ are congruent. They look like they could be, but because they are not marked, I cannot say that. No. So the answer is no. Angle TWQ is a right angle. We cannot assume that something is a right angle, and it's not marked. It's not marked, so no. D, segment TV bisects segment PQ. You're saying that when you're saying something bisects it, you're saying that it cuts it up like that. Because I don't have those marks in the drawing, I cannot assume that to be true. So that is another no.